The processor, known as the brain of a computer, is the central processing unit, CPU. It manages all the calculations and logical operations performed by the computer or any other digital device. The processor is a critical component for the computer to function, and without it, the device becomes completely non-functional. The processor takes inputs, processes them, and provides outputs. This process involves a series of complex steps, and each operation is carried out through electrical signals. Now let's take a deeper look at the processor's functions, how it works, its history, and its importance in computing. What is a processor and what does it do? The processor is an integrated circuit, IC, chip that performs all logical and arithmetic operations in digital devices, especially computers. Essentially, the processor carries out data processing, control, and communication tasks. The main functions of the processor are: 1. Data processing. The processor takes input data and processes it to produce output. These operations include arithmetic calculations, addition, subtraction, multiplication, division, logical operations, and or not, and data comparisons greater than less than equal to. 2. Control. The processor manages the program instructions, software commands, and executes them sequentially. It decides which instructions the software should run and executes them in the correct order. 3. Memory access. The processor communicates continuously with the RAM, random access memory, to temporarily store data. It reads from and writes to this memory. 4. Data communication. The processor interacts with other components to ensure the smooth operation of the system. These components include input-output devices, keyboard, screen, disk drives, software applications, and other hardware. How does the processor work? The processor's operation consists of 3 main stages, often referred to as fetch, decode, and execute. 1. Fetch. The processor retrieves an instruction from the program's memory. This instruction must be in a format that the processor can understand. 2. Decode. The fetched instruction is decoded by the processor. In this phase, the control unit of the processor determines what the instruction needs to do, e.g., perform addition on 2 numbers or retrieve data from memory. 3. Execute. After decoding, the processor performs the necessary computation or action. This could be an arithmetic operation or a data transfer operation. What happens to a computer without a processor? A processor is one of the key components of a computer, and without it, the other components, memory, storage, display, etc., become useless. Without the processor, the computer cannot perform any operations. The absence of the processor leads to the following consequences. No software runs. The processor is the only component that runs software. The software operates according to the processor's instructions. So without the processor, the computer cannot run any applications. No data processing. The main function of a computer is to process data and turn it into useful output. Without the processor, no processing occurs, meaning no calculations are made, data is not organized, and no operations are performed. The device doesn't work. The processor controls the power supply and sends the necessary signals to keep the device running. Without the processor, none of the computer's functions can be carried out. The history and evolution of the processor. 1. The early era, 1940s and 1950s, vacuum tubes and large machines. The first computers operated using large, energy-consuming components like vacuum tubes. These machines were huge and required numerous processor units to perform calculations. ENIAC, 1945, considered the first general-purpose computer. The ENIAC operated with thousands of vacuum tubes and could perform only 5,000 operations per second. However, it cannot be classified as a processor because many components worked independently. 2. The microprocessor era, 1970s. In the early 1970s, the Intel 4004 began the microprocessor revolution. This allowed all logical and arithmetic functions of a processor to be integrated into a single chip. Intel 4004, 1971, the first microprocessor, with only a 4-bit data bus, was designed for simple devices like calculators, but it also laid the foundation for computer technology. Intel 8008, 1972, and 8080, 1974, these 8-bit processors became more powerful and gained significant traction in the computer industry. 3. The 32-bit era and personal computers, 1980s. In the 1980s, processors transitioned to 32-bit architectures and gained the ability to perform more complex operations. During this period, personal computers became widespread. Intel 386, 1985, this processor, with 32-bit support and enhanced multimedia capabilities, enabled the use of powerful processors in personal computers. 4. Multi-core and faster processors, 2000s and beyond. In the 2000s, processors became even more powerful and multi-core processors entered the scene. Multi-core processors allow multiple operations to be performed simultaneously. This made multitasking and parallel processing possible. Intel Core i7, 2006, the introduction of multi-core processors led to the Intel Core series, offering high performance to a large number of users. Apple M1, 2020, the ARM-based processor revolutionized mobile devices and systems requiring low energy consumption. 5. Quantum processors, the future. The future of processors lies in quantum computing. Quantum processors can perform much more complex calculations and provide faster results than classical processors. IBM and Google Quantum Research. IBM and Google are working on quantum processors. These processors have the potential to solve highly complex problems much more quickly than traditional computers. Conclusion: the processor is the heart of modern computers and plays a critical role in the evolution of computer technology. Initially large and limited, processors today have become multi-core, powerful, and efficient. Without the processor, a computer cannot function because all the computing, logical, and control tasks are carried out within the processor. In the future, processors are expected to evolve further, and technologies like quantum computing will likely drive further advancements.